Hello students and welcome to our next video here on calculus. We introduced radians in our last video and today we're going to revisit solving trigonometric equations. I say revisit because we have done these before. The only difference now is that we're going to be doing them with radians. Other than that, the approaches won't change at all. It's just becoming familiar using radians. So let's come back. Trig functions, we remember, are periodic, so regularly we get not just more than one solution, we may very well get an infinite number of solutions to an equation unless we restrict the domain in some way. That's very common. We need to be careful when we're dealing with that though, depending on the complexity of the question. This first question here is really quite straightforward in terms of trigonometric equations. Cos x equals a negative half, and I'm looking for solutions where x is somewhere between 0 and 2 pi. Right? So, if cos is negative, then I know that's in the second or third quadrants, and the inverse cos of 1/2, right? Inverse cos of 1/2 we might remember as being 60 degrees, or if we're dealing in radians, here's my triangle here, cos being adjacent on hypotenuse, the inverse cos of 1/2 is pi over 3 radians. So I have a related acute angle of pi on 3, and I'm looking for solutions between 0 and 2 pi that are in the second and third quadrants. So here's a unit circle. These are the second and third quadrants. My related acute angle of pi over 3. Right, so we're going to subtract that from, instead of from 180, this is from pi. So pi minus pi on 3, or 3 pi on 3 if you like, minus 1 pi on 3 gives me 2 pi on 3 here. 2 pi on 3. And I've got pi plus pi on 3 gives me 4 pi on 3 down here. So there's my two solutions, 2 pi on 3 and 4 pi on 3. They fit between 0 and 2 pi, and there aren't any other solutions there. Okay. This becomes a little bit more complicated because now my original equation describes the cos of 3x. So we're going to have the same related acute angle of pi over 3. However, it's 3x that will have the related acute angle of pi on 3. And so we need to be a bit more careful with our domain here. We're going to adjust our domain straight up. And because we're dealing with 3x, right, I'm going to describe my domain, or define the domain, with reference to 3x. And if I multiply all three terms there by 3, 3 times 0 is 0, 3 times x is 3x, which is what we're dealing with. And then, of course, 3 times 2 pi is 6 pi. So I want solutions where 3x is between 0 and 6 pi. My related acute angle, just as a reminder here, negative 1 over 2 for cos is pi over 3 and second and third quadrants. Now, because, right, I am looking for solutions here where 3x is between 0 and 6 pi, right, I need to make sort of 3 laps around my unit circle here. So second and third quadrant every time, but there's my 2 pi and 3 and 4 pi and 3 as we saw for part A. But if I add, right, if I add 2 pi to that, make another full revolution to come back there, I add 6 pi and 3 if you like. So 8 pi and 3, 14 pi and 3, I get 6 solutions there. Right? You'll notice that all of them, right, from 2 pi and 3 to 16 pi and 3, all of those solutions are between 0 and 2 pi. And if I did the cos of any of those, I would get an answer of negative 1/2. So 3x is equal to all of those angles. But I don't want to solve it for 3x, I want to solve it for x. So divide all of them by 3. All right, and I get 2 pi, 4 pi, 8 pi, 10 pi, 14 pi, and 16 pi, each over 9. Okay. Rightio, that's the second one where we had to adjust the domain. Third up here, we've got sine squared. What we're going to do, we could take the square root of both sides. we have to be careful there to make sure we get a plus or minus. My preference is to use the difference of two squares. Right. So I'm going to bring the 3/4 over to the left there. It'll be equal to 0. I'll write that as a plus b, a minus b, if you like, in that form, meaning that sine x is √3/2 or negative √3/2. And for that reason, because sine can be either positive or negative, I'm looking for solutions in all four quadrants. Again, we're restricted from 0 to 2 pi, so that's easy enough. A related acute angle. Right, the related acute angle, the inverse sine of √3/2, that sine being opposite on hypotenuse, is again pi 3. Right, pi 3 radians, 60 degrees, but let's stick with pi 3. So, got a related acute angle of pi over 3, but in all four quadrants from 0 to 2 pi. So here's my circle. You can see here when I subtract or add pi over 3 from my x-axis, I produce four solutions there: pi on 3, 2 pi on 3, 4 pi on 3, and 5 pi on 3. Right, all of those are valid solutions. One to go. I'm pretty sure this is the last one. Now this is looking a bit complicated, and the best thing to do here is to recognize that this is vaguely in a quadratic form, to use a substitution. So let's let u equal cos of x. And then we can rewrite our expression there as 2u squared minus u minus 1. Then factorising that non-monic quadratic is going to give us 2u plus 1, u minus 1 equals 0, meaning that u is a negative half or u equals 1. Substituting back gives us cos x of negative 1/2 or cos x equals 1. And we're looking for solutions between 0 and 2 pi. Now, cos x equals a negative half is going to have two solutions in the second and third quadrants. So far so good. In fact, we've recognised those. We probably can remember what they are: 2 pi and 3 and 4 pi and 3 from the previous examples. Right, these questions are related to each other. Cos x equals 1, maybe remembering the graph of y equals cos x is going to help us there, and carefully examining the domain here. So 0 is less than or equal to x, is less than or equal to 2 pi, because the cos of 0 is 1 and the cos of 2 pi will be equal to 1, but they're the only solutions. So I should have four solutions here. Now, these are my solutions, and the best way I think to visualize them now, here's my graph, right? The red line here represents y equals cos x from about 0, x equals 0 to x equals 2 pi. That's my red line. The blue line here is the line y equals a negative half. So where the blue line intersects the red line is where cos x equals a negative half, and this gives me those 2 points of intersection. Right? My y value is negative a half. That's fine. We expected that, we anticipated that, but 2 pi and 3 and 4 pi and 3, you can see the x values. That's where they intersect. My green line represents the line y equals 1, because I want to find where cos x is equal to 1, where it matches that line there, where they intersect, and that occurs here at 0 and at 2 pi. Yeah, so there's my four solutions. Pretty sure that's it. Now, if you've got any questions there, it's a fairly complicated exercise, but we have done trigonometric equations before. So, mostly it's just a matter of dealing with radians there. Anyway, if you've got any questions, make sure you ask me in class. Otherwise, I'll see you for the next and final video for this exercise, arcs and sectors. See you then.